Hi friends, welcome on Yourpedia, the platform where you are getting the module for भारत इलेक्ट्रॉनिक्स लिमिटेड सेकेंड टाइम। दूसरी बार रिक्रूटमेंट आया है। 14 नवंबर को इसकी लास्ट डेट है फॉर्म फिलिंग की। अगर नहीं भरा है तो आज 13 नवंबर है, कल 14 नवंबर है, फॉर्म भर दीजिए। मैकेनिकल, इलेक्ट्रॉनिक्स, इलेक्ट्रिकल, कंप्यूटर साइंस सारी ब्रांच के कैंडिडेट्स के लिए बहुत अच्छी अपॉर्चुनिटी। और सुनने में ऐसा आ रहा है कि BEL बहुत ज़्यादा रिक्रूटमेंट कर रहा है और 2025 में डबल रिक्रूटमेंट हुआ, तो 2026 में भी रिक्रूटमेंट के चांस हैं। और BEL का जो एग्ज़ाम आता है फ्रेंड्स, द एग्ज़ाम पैटर्न इज़ typical pattern. I mean, if you see the previous year's question paper, you will get an idea from where the question is asked. And Yourpedia has given the best module to you after successful completion of first module, which exam CBT was in May 2025. Now we have come with even better improvement, and this time we are launching a book also. So you will get additional book also within a week or so. You will get the announcement of that. And in my opinion, if you prepare it really well, you can get more than 90, which is required for cutoff for CBT. So 90 score out of, I am saying 125. So 80 in technical out of 100 and 20 plus in aptitude out of 25. If you score, you will surely get very good, cutoff you will clear, and then interview followed by interview. So that is how it has to be, and paper is pretty simple of BEL. My today's video is related to one of the topics in mechanical engineering, which is not very difficult, but obviously you don't study these kind of topics for other exams. It is a tailor made for BEL. So mechanical properties is the topic which got 6-7 questions, 7-8 questions, and again you are going to get 7-8 question, maybe 10 out of 100 question in technical. And this topic is a common topic for strength of material, for engineering materials, that is material science, and for production engineering. So if you club it together, you'll find that okay, this is the topic which you find everywhere. So you prepare this topic. I have separated this topic separately for you, and there is a lecture also of engineering materials. This video is related to previous year question, that means BEL के actual question, solution of that, and then expected question, and then learning content, tabular learning content. Tabular learning content is like a data information, sort of what you get in data books. So that tabular content which will help you to revise the topic in terms of couple of tables only, right? So this is Bharat Electronics Limited module, and this is for mechanical properties. So these were the actual question asked. So material that can be drawn into wires under tension without breaking, obviously. So ductility, what is ductility, what is hardness measuring devices, what is brittleness, what is stiffness, what is the relation between stiffness and brittleness, and how do you measure all these properties from the stress strain diagram. So as I told you, this topic is combined topic for material science, strength of material, engineering materials, and production engineering. So you have to think of it as a combined topic only. So stiffness is something which you should know, and brittleness, ductility, if x-axis, strain axis is more, this is ductile, otherwise this is brittle. हार्डनेस यू कैन नॉट मेजर फ्रॉम स्ट्रेस स्ट्रेन डायग्राम से, हार्डनेस का पता नहीं चलता। विकर हार्डनेस पे क्वेश्चन आया है, तो ब्रिनल पे भी आ सकता है, रॉकवेल पे भी आ सकता है। सो आई हैव गिवन यू दैट टॉपिक ऑल्सो इन दिस लेक्चर। सो ऑब्वियसली द आंसर इज डक्टिलिटी, एंड व्हाट इज डक्टिलिटी? इट इज द एबिलिटी टू ड्रॉ इनटू द wires without breaking, and then there is a similar property which is called malleability. तो ductility and malleability का पता stress strain diagram में x axis पे चलता है. You get to know about the ductility and malleability from x axis of stress strain diagram. Incidentally, gold happens to be the most ductile and most malleable material. So spreading it into sheet is malleability. And when you check malleability, you apply compressive force. You hammer it and spread it into sheets. Ductility के लिए you apply the pulling force. So tensile force is applied for ductility, malleability, compressive force is applied. And ductility is capacity of material to undergo plastic deformation along x-axis, right? So under tensile stress. So if stress strain diagram is plotted, and you know stress strain diagram is universal testing machine is the device on which you plot stress strain diagram, and in universal testing machine the pulling force or tensile force is applied. So typical stress strain diagram eventually is engineering stress, engineering strain, and not true stress strain diagram. Engineering stress, engineering strain में आप पुल करते हो और टेंसाइल फोर्स अप्लाई करते हो, और then wire drawing में this gets used. And the materials which have very good ductility, gold is the maximum ductile. That is the reason gold is used so as ornamental material. Copper, nickel, steel is a tough material, so crack propagation or crack is not there, so that is the reason. Obviously electric wiring में why do you use copper wires and all, reason is one is conductivity, another reason is ductility also. So so brittleness is opposite of ductility, so lesser ductile is a brittle, so it is elastic deformation resistant to electric deformation, so that is brittle. So something which is not ductile is a brittle. And how do you know on stress strain diagram whether a material is ductile or not? So on the stress strain diagram, friends, if I give you, this is the norm, this is the engineering stress, engineering strain. So if the percentage elongation, that means strain is calculated in absolute units also and percentage also. If the fracture point, now this is the fracture point, like if the fracture point is beyond 5% of the strain, then it is ductile, otherwise it is brittle. That is rough idea. How do you know whether it is a ductile or brittle material? तो वहाँ से आपको पता लगता है कि ductile है या brittle है. So there are many manufacturing processes, wire drawing and all in which you test the ductility of the material. So ductility का पता stress strain diagram पे कहाँ पे पता चलता है वो हमने discuss किया. मैंने आपको बताया brittle means in the brittle and ductile the main difference on the stress strain diagram is plastic deformation region. So plastic deformation region is almost missing in the brittle materials. So if you see, this one can be elastic material and right side can be plastic deformation material. So if you do not find the plastic deformation, this is the plastic deformation material, if you do not find plastic deformation material, plastic deformation region, तो वो brittle material होता है. एक और डिफरेंस ब्रिटल और डक्टाइल का स्ट्रेस स्ट्रेन डायग्राम पे, एक तो मैंने 5% वाला कंसेप्ट दिया, 5% कंसेप्ट. सेकंड आई टोल्ड यू plastic deformation is not there in the brittle. Third, I am telling you yield point and ultimate point are very close in brittle. So this is the yield point for ductile, this is the fracture point for ductile. You see the difference, but you see this here, yield point and fracture point, yield point, ultimate point, fracture point, all close. So basically in the brittle these points are very close, in the ductile they are far away. तो ये है आपका typically जो brittle है, mode of failure is fracture and this is the plastic region which is your ductile material. तो ductile और brittle के कुछ एग्जाम्पल, कुछ नाम कौन से हैं और किस तरीके से उनके प्रॉपर्टीज होती हैं, what is the application that you should read, right? Glass, ceramic, cast iron, concrete, stone, these all are brittle materials. Sudden failure, fracture, that is what the brittle material is all about. So which properties of engineering materials? These are the actual Bharat Electronics Limited questions. Describe total amount of energy that material can absorb before it fracture. Total. So total is toughness. So there is a modulus of toughness, there is a modulus of resilience. Let me give you the stress strain diagram of mild steel. This is the elastic region, area under elastic region, and the unit of stress strain diagram, this is half of stress into strain. If you see this, stress is load per unit area and strain is change in length over original length. So load force into deformation is the strain energy. This becomes strain energy. Any idea what is the unit of strain energy? Joule. And this is the area of cross section, this is the length per millimeter cube. Millimeter is a very small unit. So the unit of stress strain diagram is energy per unit volume. Strain energy per unit volume. Now if that strain energy is elastic, strain energy per unit volume, it is modulus of resilience. But if I add entire till toughness, entire elastic and plastic, it becomes modulus of toughness. You know that. Now why it is called modulus? Because per unit volume. अगर मैं लोड डिफॉर्मेशन डायग्राम लूं, दिस इज द लोड फोर्स डिफॉर्मेशन डायग्राम, तो एरिया अंडर दैट विल बी द स्ट्रेन एनर्जी इन जूल. लोड डिफॉर्मेशन डायग्राम का एरिया क्या देता है आपको? स्ट्रेन एनर्जी. स्ट्रेस स्ट्रेन डायग्राम का एरिया आपको क्या देता है? व्हाट डज द एरिया ऑफ स्ट्रेस स्ट्रेन डायग्राम गिव्स यू? what does it provide you? So that is the strain energy per unit volume, and it has two names: modulus of resilience, modulus of toughness. Modulus of toughness till fracture point, modulus of resilience till elastic या yield point. Cast iron is the best, very good in resilient material. It gives back you the energy. It undergoes deformation but gives back you the energy. Whereas steel is tough material, right? So the typically springs should be resilient. They should not be tough. They should be resilient because they should give you back energy and not get deformed. So toughness and resilience we'll discuss in detail there. So this is toughness, friends. Now what is toughness? So entire energy up to absorb before it undergoes rupturing or fracture. So I already told you elastic plus plastic region. Elasticity is the ability, toughness. What is elasticity? What is toughness? That you should know, right? So strength plus ductility is toughness. Let me give you this dimensional information about stress strain diagram. Now this side is strength. Y-axis of stress strain diagram gives you strength. Property is strength. Stress is not a property. Stress is load per unit deformation. That is basically resistance force induced per unit area. That is called stress. But limiting stress at which body may fail, that is called strength. Now strength y-axis and strain or ductility or malleability you get to know about x-axis. Area is both stress, strain, half of stress into strain y-axis and strain is x-axis. So when you multiply these two, you get toughness. So toughness is a combination of strength and ductility. Material which is strong and ductile also is called tough, like steel. Material which is strong but not ductile, cast iron. Cast iron is a brittle material, so it is not tough. It may be resilient, right? Now see these diagrams. So typically mild steel में ये 25% है, fracture point is till 25% mild steel में, you should understand that. So this 25%, this is ultimate strength. So this number, these strains values you should remember, because in Bharat Electronics Limited you may get these kind of questions up to what strain value you are getting what. So yield strength कितने % तक होता है, so those ideas you should have. Elastic material, plastic material, examples उनके. So typically spring should be resilient material, right? All the metals are basically elastic. Yeah, so this is for your information, friends. Third question which was asked was shearing of rivets. Rivet को तोड़ना, shearing. Let me give you a rivet, let's say. Now मैंने उसको यहाँ से shear कर दिया, so it will look like cross section area. मैंने यहाँ से उसका तोड़ दिया, right? तो मैंने यहाँ से shear कर दिया, तो one surface gets sheared over another surface, right? Maybe you are developing this concept, how I am shearing it. तो sliding of one layer tangentially on the other is called shearing. उसके लिए shear force चाहिए. तो अगर मैं आपको एक diagram दूँ friends, 3-dimensional diagram of shearing phenomena. Suppose I apply force like this. This is the area of cross section. So this is force per unit area is the shear stress induced. So I am applying shearing force. And what happens when you apply shear force? There is a shearing strain. There is a angle phi. Shear strain it is called. So there is a small inclination deviation, that is called shearing strain. Right. So this is the shear strength which actually is evaluated. So rivets के अंदर जहाँ पे shear force induce होती है, तो shear strength is something which is important, and typically shear strength is lesser than the tensile strength. Typically, I mean, if shear strength is almost half of tensile strength, brittle में shear strength is more than half of tensile strength, or ductile में shear strength is less than half of tensile strength. That is what you should know, and they are the material properties. So this is what you should be aware. Torsional stiffness. Now what is the torsional stiffness? That is what you should know. Torsional stiffness is torque. You know what is the torque? Torque is can be applied by torsion effect can be by by force, equal and opposite forces acting on particular body, or there can be twist on the shaft. So that is, let us say this is the shaft I am giving you and I apply a torque on this. मैंने एक shaft आपको दे दिया. Okay, so I am giving you a shaft, friends. This is the shaft. This is the cross section of the shaft and applied torque on this. तो क्या होगा, let us say जब मैं टॉर्क लगाऊंगा तो वो टिल्ट होके ये पॉइंट P डैश के ऊपर चला जाएगा. ऐसे जब मैं टिल्ट करूंगा ट्विस्ट आ जाएगा. देयर इज अ ट्विस्टिंग एक्चुअली फिनोमिना. सो इफ यू सी देयर इज गोइंग टू बी द ट्विस्ट. तो T over J is equal to tau over R is equal to G theta over L. Now this theta is the angular twist. So I gave a torque मतलब घुमाना, और उसके बाद ये ट्विस्ट कर गया, पूरे के पूरा सरफेस ट्विस्ट कर गया अराउंड द एक्सिस. दैट इज torsional effect. G is the modulus of rigidity, L is the length of this shaft, T is the torque which I applied, J is the polar moment of inertia, tau is the torsional shear stress induced, R is the distance at which it is induced, radial distance. So that is how it is. So torsional stiffness क्या होती है? Torsional stiffness, torsional rigidity is the resistance of the shaft to twist when torque is applied. You know what is the torque? And torsional stiffness जो है वो मटेरियल का प्रॉपर्टी है that resist the shear deformation, और ये प्रॉपर्टी है मटेरियल का. ये टॉर्शनल स्टिफनेस कैसे निकालते हैं, ये है उसका फॉर्मूला. मैंने आपको जो इक्वेशन दिया था T over J tau over R G theta over L. So अगर मैं G J over L कर दूं, G J over L, तो ये हो जाएगा T over theta. So torque per unit angular twist, torque applied per unit angular twist is the torsional stiffness. तो जो स्टिफनेस है, रिजिडिटी है, दोज थिंग्स वी विल डिस्कस. एक्सियल रिजिडिटी, स्टिफनेस, स्ट्रेंथ ऑफ मटेरियल में तुम पढ़ते हो. एज आई टोल्ड यू, दिस इज द कॉमन टॉपिक फॉर स्ट्रेंथ ऑफ मटेरियल साइंस एंड प्रोडक्शन इंजीनियरिंग. सो torsional stiffness you will study in the, this equation you will study in the strength of material. I am sure you will do that. But यहाँ पे याद रखना, ये आपका torsional stiffness होता है. Modulus of property, modulus of elasticity is something which you get as a slope of stress strain diagram, and this is something which is related to bending. So if I normal stress, normal strain, if I give you, this is the angle theta, so tangent theta is a stress over strain, that is the Young's modulus of elasticity, and this is something which is related to bending, because bending mein you apply the load, and when you apply the load the body undergoes some kind of deformation. So that is the bending के case में आप modulus of elasticity की बात करते हो, this is the E, right? So this is the shear modulus of rigidity का concept. This is how you should get it. Take this document, I have provided this in the your WhatsApp group, so please you can take it from there. Now hardness test, friends. Hardness is something which is resistance to scratch. It is a surface phenomena, not a body phenomena, and it is related to the grain boundaries actually. And this is, you cannot, hardness ka measurement you cannot do from stress strain diagram, but yes, there are different scales on which hardness is calculated, like Vickers scale, Rockwell scale, all these scales. So Vickers hardness testing tester is there, which has a square pyramid. So this is Vickers hardness, is a diamond indenter is there. As you can see, this is a indenter जो indent करता है, और वो diamond indenter का angle force 136 degree angle होता है. Diagonals D1 D2 you measure, and in terms of D1 D2 you calculate what is the hardness number. स्क्वायर बेस होता है इसका, जैसे बेस आपको दिख रहा है स्क्वायर है, दिस इज अ स्क्वायर, राइट? सो बट इट इज लुकिंग लाइक अ पिरामिड. So the included angle between opposite faces, as you can see, is 136 degree. So this is Vickers hardness tester, friends. Diagonal D1 D2 you will measure, and in terms of D1 D2 there is a formula, you can calculate the, and the formula will not be asked. I don't think formula will be asked. but these basic things can be asked, and in the tabular information below I have provided you these details also. Next question asked was related to fluctuating load and fatigue failure. So you know, endurance limit, fluctuating load, cyclic load, fatigue failure, all these terms are related. When the load is cyclic, कभी compressive कभी tensile, cyclic है load. When the load is cyclic and when you apply sometime tensile, sometime compressive, and it is, you know, endurance is checked and fatigue failure is checked. So how do you define it? Maximum stress below which material can withstand infinite number of stress cycles without failing by fatigue. Endurance limit, this is the definition of that. Shafts are subjected to fluctuating cyclic loads. So fatigue is something which is related to cyclic loading, and shafts are subjected to cyclic loading, and hence fatigue strength of the shaft is to be calculated. Friends, you should be very clear when shear strength is to be seen, rivet, when endurance or fatigue strength is to be seen, shaft, when tensile strength or yield strength is to be seen, normal loading. So in case of ultimate tensile strength or yield point, basically yield strength is the design strength, not ultimate strength, is for static load, static mode of loading. That is how it is to be done. So rigidity, stiffness are the terms which are related to static loadings, right? Fatigue is more related to cyclic loading. Now what is endurance limit definition? That also you should go for. I am giving you this detailed thing to understand, but you know, this is taught in the your lectures also. Endurance limit is determined by fatigue testing. SN curve आप करते हो, मशीन डिजाइन के अंदर होता है ये SN कर्व, वहाँ पे आप स्ट्रेस वर्सेस नंबर ऑफ साइकिल निकालते हो और वहाँ पे आपको इससे पता चलता है फटीग स्ट्रेंथ वगैरह, एंड्योरेंस लिमिट वगैरह कैसे होगा. सो यू कैन कैलकुलेट अबाउट दैट. नाउ on the basis of these were the questions which were asked in the previous years in Bharat Electronics Limited. On the basis of that friends, multiple expected question. अब क्या आ सकते हैं? डक्टिलिटी आया तो मेलिबिलिटी भी आ सकता है. What is the meaning of malleability? How ductility, malleability are related? डक्टिलिटी क्या होता है, मेलिबिलिटी क्या होता है, तो कौन सा मटेरियल बहुत डक्टाइल है, कौन सा मेलेबल है, इलास्टिसिटी क्या होता है, प्लास्टिसिटी क्या होता है. सो नंबर ऑफ क्वेश्चंस आर फ्रेम्ड फॉर यू ऑन द बेसिस ऑफ दीज क्वेश्चंस. प्लीज गो थ्रू दीज क्वेश्चंस. सेल्फ एक्सप्लेनेटरी हैं, हार्डली एनीथिंग इज रिक्वायर्ड टू अंडरस्टैंड, बट यू शुड गो थ्रू इट. हाँ, सबसे इंपॉर्टेंट पार्ट जो योरपीडिया का है, जो आपको हेल्प करता है टू क्रैक दिस एग्जाम विद इन 60 days or 2 months, and that is also part of our book. So that is tabular learning content. Tabular learning content में हमें सारा जो चीज़ होता है जो आपको पता होना चाहिए at the 11th hour to go before the exam, that is provided like this. Elasticity, plasticity, modulus of rigidity, ductility, brittleness, toughness, ये क्या चीज़ होती है, common hardness testing machines, scales क्या हैं, रॉकवेल, विकर, नू, ब्रिनल, कितना आपको नॉलेज होना चाहिए, तो यहाँ से एग्जाम निकल जाएगा. सो रिवाइज इट एंड देन देयर आर अदर क्वेश्चंस आल्सो फ्रेंड्स. तो ये आपके पास एक पूरा क्वेश्चन बैंक, प्रोडक्शन इंजीनियरिंग, इंडस्ट्रियल इंजीनियरिंग, मटेरियल साइंस, सारे के सारे सब्जेक्ट्स का मैकेनिकल का. रिवाइज दिस 4-5,000 क्वेश्चंस एंड डू द टेस्टिंग एवरी डे. आई एम श्योर इट इज़ वेरी सिंपल एग्जाम. BEL, वंडरफुल अपॉर्चुनिटी, डोंट मिस इट. थैंक यू.